Here's an example of a parallel circuit where we have three resistors in parallel with a 25 volt power supply. So the first thing we're going to do, if you take a look at the problem, I have a table here that we're going to need to complete that lists all the voltages for each resistor, the resistance for each resistor, the current through each resistor, and then the total voltage, total resistance, and the total current. So I'm just going to label the resistors, and it really doesn't matter which one's which. I'll just call this one R1, then R2, then R3. So just moving from left to right, I'll just label those. So I know from what I have given that R1 is 10 ohms. So I'm just going to put this in my table. I know that R2 is 15 ohms. And then I know that R3 is 20 ohms. So knowing what I know here, I also know that the total voltage is 25 volts. Since I have a parallel circuit, I know that the voltage drop across each branch is going to be equal, and it's going to be equal to the voltage drop that we have in a power supply. So the drop here is 25 volts, the drop here is 25 volts, and the drop here is 25 volts. So for all three of these resistors, the voltage drop across the resistor is going to be 25 volts. So that I do know, and that's pretty important. Now the next thing I can do, and I have a couple of choices here. I could use my resistance rules, and I could do 1 over 10 plus 1 over 15 plus 1 over 20, then 1 over that to get my total resistance. But I'm not going to worry about that because there's another approach to solving this problem without having to worry about that. What I'm going to do next is, since I know the voltage and the resistance of each resistor, I'm going to find the current through each resistor. So if I wanted to find the current through resistor 1, I know that V equals IR from Ohm's law. So I know that the voltage across resistor 1 is equal to the current through resistor 1 times the resistance of resistor 1. So if I plug in what I have, I know that the voltage drop across resistor 1 is 25 volts. I don't know the current, but I know that the resistance is 10 ohms. So if I wanted to find the current through resistor 1, all I have to do is take the 25 volts divided by the 10 ohms, and that would give me my current of 2.5 amps. So 2.5 amps is going to be the current through resistor 1. Now if I do the same thing with resistor 2, so I take the 25 volt voltage drop divided by the 15 ohm resistor that we have, I'll get a 1 2/3 amp current. And then if I do the same thing with I3, I'll get 1 1/4 or 1.25 amps for the current through resistor 3. Now I know that the total current is the sum of my current. So if I add these up, so if I take my 2.5 plus 1.25 plus my 1 2/3, I'll get a total of, and I'll just round this one to a fraction now, or sorry, I'll round it to a decimal. It's going to be 5.417 amps. So 5.417 amps is the total current going through the entire circuit. So if I wanted to find the total resistance now, what I could do is, instead of doing 1 over 10 plus 1 over 15, etc., 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 I can just use my Ohm's law again. V equals I times R. And I know that the total voltage is equal to the total current times the total resistance. So I can figure the total resistance just by using the total voltage and the current, the 5.417 amps that we just figured out, in Ohm's law to figure that out. So if I take 25 volts divided by my total current, I get a total resistance, an equivalent resistance of 4.615 ohms. So you notice that the resistance is lower. It is pretty much what we expected it to be. In fact, if we actually just double check this, it's probably not a bad idea just to double check it, just to make sure that we're doing this right. If I take 1 over 10 plus 1 over 15 plus 1 over 20, and I take 1 divided by that entire thing, let's just do this really quickly. 1 divided by 10 plus 1 divided by 15 plus 1 divided by 20, then 1 divided by that, I end up with that same value. It's 4.615 ohms. So you can see you can do it this way using the resistors, or you can do it using Ohm's law. It's really up to you. It's not a bad idea once you get the table finished to double check your numbers using both methods just to make sure you didn't miss something along the way.